So you're looking to take your React skills to the next level and build blazingly fast sites? Well, I might have just the tool for you. It's called Fresh, and not only does it build a blazingly fast site, but it also gives us a key insight into the really important upcoming architecture called Islands architecture. Let's get right into it. Let's start out by talking about what we're going to learn in this video. We're going to learn about Deno, which is an alternative to Node. We're going to learn about Fresh, which is a web framework that's built on top of Deno. We're going to learn about Directus, which we're going to use to hold all of our data and support our REST call interface, but they also support GraphQL if you want to do that. And we're going to learn about the Islands architecture, which is really important because I think it's actually an up-and-coming thing that you want to know about in your career, because this is one of the ways that sites are moving towards an MFE architecture, or micro front-end architecture, but it's simplified versus our existing micro front-end variants. All right, so this is the site that we're going to build today. It's a Pokemon site. All the data here is coming from Directus, and you can do some neat stuff with it. For example, you could type in a search term like Ivy, get your Ivysaur and your Snivy or whatever. You can get details about the particular Pokemon. It comes up with a detail page with all their attributes. Let's go back to the home page for a second. Another thing you can do is you can add the Pokemon you like to a list. You see that the list increments up here in this section, and then you can go to the /list route, where we see our list of the Pokemon that we have selected. And you can also go to a search route, which gives you a dynamic search, for example. So let's go in this case, Ivy, and it automatically updates the list of Pokemon after every keystroke. Cool. So I think this is actually going to show off most of the features of the Fresh framework. All right, cool. So the reason I constructed it this way is so that I could show you all of the different features of the Fresh framework. And also Deno deploy, which is how we get it out in the real world. You'll see right now that this is on the Jher fresh Pokemon 1.deno.dev. That's a Deno deploy site that isn't hosted by me, isn't localhost. So it's really cool. And it is super blazingly fast to both write in and deploy. And the web pages themselves are really, really fast. So what is Fresh? So this is the Fresh homepage. And talks about how this is all the next gen web framework, and in particular, this islands-based client hydration for maximum interactivity thing, which we'll get into as we go over it. There's also the zero runtime JS overhead, which means that if your pages don't have any interaction in them, there will be no JavaScript downloaded to the browser, which makes them really, 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 really fast. Okay, but enough talk, and let's actually try it out and get into it. So what I'm going to do is I'm going to go over to my terminal. So into my 2022 directory, I'm going to run this command. This is going to be a Deno run command. This basically grabs code from online. In this case, the fresh Deno dev template. That's going to go and give us the template for Fresh, which is the web framework. And then I get to call it whatever I want. So I'm just going to call it Fresh Pokemon. And now it's going to go build that directory out for me. And I'm going to say that I do want Tailwind, and I do want it to be set up for VS Code. Now I'm going to go into my Fresh Pokemon directory and bring it up in VS Code. So what have we got here? We've got islands. That's where we're going to put our interactive piece of JavaScript. We've got our routes, which is equivalent if you're into Next.js, the pages directory. We've got a static directory where you can put static assets like images. And then finally, you've got a little utils directory where you can drop, friendly utils and stuff. Now, one thing that's really different between Node and Deno is that you don't have a package.json. What you have instead is this import map. And this import map basically says, for this particular library, like Preact, which is what we'll be using in this case, we're not going to be using React, we're going to be using Preact, but your skills are transferable, so that's okay. You're going to go and get that Preact from this URL. And that's how packages are deployed in Deno world. They're deployed via URL, and this import map just makes it a little bit easier. You could actually just put in the code import and then give it a URL, and that would be fine. But the import map just makes it a little bit easier. Another kind of part of package.json is taken up by this Deno.json, which has things like tasks, which are the equivalent of scripts. So in this case, there is the start, and then we also have that import map, which is pointed to by this import map key. Okay, so let's actually run this thing. So we're going to do Deno, task, and then start. And that's how quickly it comes up. So there you go, boom. Now our site's up. We've got this little static asset over here, which is the lemon. We've got our piece of text in here, and then we got an interactive section where we can go and add and subtract items from a counter. Now, without getting into too much detail quite yet, this counter is an island. Everything else on this page, I mean, there isn't really all that much to it, but everything else on this page is static. And in the middle of this static world of HTML is this one called out island, which is the only piece of interactivity. So the only JavaScript that we're actually downloading to our browser at this point is just the JavaScript to support rendering out just this particular component. We'll get into that more in a bit. So let's go over to our index page and get our basic app set up. So we're going to go over here into routes, and I'm going to get rid of this name route because we don't need that at the moment. And I'm going to go and take our index and change it. So there will be some copying and pasting in this video. Sorry, I'm not going to go type everything out directly. So here's our home page. We're going to have a form input at the top. It's going to have an input field and a button called submit. And then down here, we're going to put our list of Pokemon. But at the moment, we're just going to have an empty array and a div. So let's hit save. And there you go. There's our search. And this is what the page is going to look like. But we're going to have a header up there, and then we're going to have our Pokemon. But the next thing we need to do is we're going to go get our Pokemon. So where do we get our Pokemon? We get them over on our Directus site. So here's Directus. This is an online hosted DB, and I have just one table in here. It's got all of our Pokemon in it. This is just a particular way of rendering this table. You can go and change whatever you like. You can make little cards, big cards. You can look by, whatever. And then you can click on one and you can get all of the information about this particular type of Pokemon, all of its stats and everything else, and its image. All of those images are stored in a file library that gives you all of the assets. I've asked the Directus folks to help me out by giving me a way to allow you to clone this data, and it should be in the description by the time this video goes live. If not, I'll keep the description updated as we come up with a solution for that. Currently, the only location for this data is my particular Directus DB, so that's not particularly scalable. Well, anyway, we'll figure that out and we'll put that in the description down below. All right, so what you can do once you have this is you can go and take your administrator user, and then you can add a token to that, and then that becomes your API token for that particular user. Now, obviously, you might want to create like a downgraded user that only has read permission and put a token on that and use that. But that token is what you then use either for the GraphQL API or for the REST API. And both those APIs are generated automatically by the structure of the database that you put together. For example, let's take a look at this REST query. We're going to MyDB, which is this 4HE1 whatever, and then we're giving it my access token. I literally just went to a GUID generator, generated this GUID, and there you go. And now I'm telling it to give me a limit of 9 off of the Pokemon list. So it's /items and then the table name, in this case Pokemon, and that's going to give me my data. Pretty cool, right? And you can do filtering like so. Let's add on a filter key. We can say that the name contains Ivy, and that's how you do a basic name filter. You could filter on whatever you like. Actually, I've set the attribute values to strings here. Really, they should be numbers. I'm sure if I had them as numbers, you could do things like, give me anything that's got hit points over X or whatever. It's a full-featured database. It's got all of that baked into it. It's really nice, actually. I'm really, really impressed with Directus, and I'm just showing you the bare scratching of the surface of what I can do. But let's go and bring this into our Ivy app. And the way that we do that starts by defining the structure of one of our Pokemon. So we're going to define in TypeScript this response type. So we'll go over here to our Visual Studio Code, and in utils we'll create a new file called types.ts. And into that we're going to set our Pokemon type. It's going to have an ID, name, type, and that corresponds to the different keys here. So this just kind of marshals the types that are coming in from Directus into what we need for TypeScript. All right, now let's go bring that over into our index. And we do that simply by just using an import statement. So we import Pokemon. And if it's a file, the only difference between this and Node is that you actually put in the extension, where in Node you don't put in the extension. Okay, one more thing, we have to define the DB and the access token. So we're going to use environment variables for that. So I'm going to go create another file called end.ts. And in there, we're going to have our DB and token constants defined, and we're just going to get those from the environment. Now, this is a bit different from Node, where you would do process.env.db. In this case, you use deno.env.get. Okay, so let's bring those in as well. We're going to bring in the DB and the token, and we're going to do that from our env. So now we need the data. And in order to do that, we need to define handlers for this page. Now, those are going to get run on the server or in the Lambda. They're going to go get data, and they're going to return that as props to this home component. Really equivalent to what you'd see in Next for like get initial page props or get server-side props. So the way that we do that starts by bringing in the handlers definition and the page props definition from the fresh server file. And then much like we would do in Next, we define an exported function, in this case, handler. And that's defined as a handler's function that returns an array of Pokemon. So what that's going to do then is we're going to fetch that list of Pokemon. You're going to get the result in JSON. And then we're going to do our context render. And that's going to call the home component. And then we're going to give it the Pokemon.data that we just got back. Because if you take a look over here, the response has one key in it, and that key is data. So what we really want is this array. So that's why we're going to dereference the result there by data. Okay, so that's going to give us back our Pokemon. That's going to pass us on to home. So we need to tell home that we're doing that. So the way we do that is we then define this props as page props, and we give it, again, what we're expecting here, which is that Pokemon array. And then that comes in as props.data. Somewhat confusing, I get it, because we have data back here, but it's a different data. This is coming in from this props. And then we're destructuring it to get out that Pokemon. Okay, and then to test that this is all working, we're just going to go and add a JSON stringify down here. And let's take a look. All right, there we go. So what's happening here is that we are doing our SSR, and because we don't have that DB or that token environment variable set, it's actually not making the correct URL request. So let's go back and reboot our app and then stop it. And then I'll go back and look for DB. And there we go. Okay, so the command line is going to be DB equals, and then that's going to be that 4H because that maps to this 4H up here. That's the unique key for my particular database. And then the access token here maps to the access token that I've defined. Again, I just kind of got that as from a GUID generator, just totally made up. You can define whatever you want. And let me start it up and see how we go. Okay, there we go. We got our JSON. How cool is that? All right. And all right, let's actually render this thing and make it look pretty. So the way that we're going to do that is we're going to define a component. So now I don't actually see anywhere to define a kind of unique component that isn't a route or isn't an island. So what I'm going to do is I'm going to create a new folder called source. And in there, I'm going to create a Pokemon card.tsx. And I'm going to put my implementation of a Pokemon card. It's going to take a Pokemon, which is defined as a Pokemon from our types. And then it's just going to give us an image for that Pokemon. It's going to wrap it in a nice little rounded border. This is all Tailwind stuff. It's going to put the name up there. So let's go back over into here, into our index page, and we'll bring in that Pokemon card from source, Pokemon card.tsx. And then all we really need to do is go down here and actually bring it into our array. So we've got our Pokemon array here. And then I'm going to do Pokemon, and I'll give it a key, just as you would in normal React. In Preact, you do the same thing. And then I'm going to pass along the Pokemon data and save, and let's take a look. Oh, nice. Really important at this point is understanding that none of that React, and we were used to React going to the page. None of that React is actually going to the page. It's all done on the server side. So let's go over to, for example, this network panel, and I'll hit refresh. We're filtering down to just JS files, and you can see that the only JS file coming in is this refresh JS file. And that's just for doing live reloading in dev. There's no data, none of our code's coming in there. And I think it's 373 bytes to basically just monitor and I guess probably set up a WebSocket to the server and get, hey, I'm ready to refresh, and there you go. So that's it. We're not actually sending any JavaScript to the client for this. So that's one of the real reasons that right out of the box, this is just so much faster than a Next app or a Create React app, because there's no client-side reconcile phase. So what is a reconcile phase? Well, this is really important to understand when it comes to React and how React renders pages, particularly if you're doing server-side rendering. So what happens with server-side rendering is that you go get the data on the server then builds your entire React tree in memory. So it's building out all those nodes by running all of your functions and class components on the data that you just got back from the APIs. Then React is going and it's rendering that entire tree to a string, and that's being sent off to the client, along with some serialized data. So all of the data that you got back from the API is also serialized in that payload, usually the script tag at the top of the page. And then on the client, you render the page. So cool, you can see it. But before you get to anywhere where you can actually click on anything, you have to parse through the bundle. Then you have to go and initialize your app with the frosted state that was brought in that script tag and the header. Then you got to run your application and build that VDOM node in memory. Then you got to go and diff that VDOM node against the existing DOM nodes that are on the page. And then you're actually running and you can start fielding clicks. So if you're building an entire page in React from tip to tail, every single thing on that page is going to be need to be rebuilt in memory and then checked against what's actually on the page. And that's all called reconciling. And that's why we have some performance issues on sites that use React for absolutely everything on the page, because it's just a long time to actually do that. If you've got a very complex set of components and a big hierarchy, it just takes a long time to get through all that. Okay, so this gets around that by basically doing all of that on the server, and then you can actually pick out pieces of the UI that you want to make interactive. That's called islands. We'll get into that in just a bit, but let's kind of continue on this path of getting just this static version of this going. So the next thing we want to do is support this lookup here. So let's do Ivy, for example, and you can see that we get Q equals Ivy up there, but we're not actually doing anything with that. So let's actually support that. So what we need to do is go back over here to our get, and we need to look at this request because that request has a parameter for the Q. So with that, we are going to go get the URL. Then we're going to go and look for that Q parameter, and then we're going to build that filter. So this is the Directus filter. So we're going to say filter, we're going to filter on the name field and say that we would contain, and then we're going to encode a URI component for that query, so that IV. And then we're just going to add that to our URL. Okay, let's take a look. And there we go, boom. Because it came in here as IV, then we automatically applied that filter to that, and that's how we pared down that list. And again, all that was done on the server, never hit the client or anything like that. And this is just a basic form, and we did a basic form query submit to the page, and that's how you got the Q equals IV. That's just a basic functionality of the browser. But of course, we want to put this IV into here, right? We don't know anymore that that's what we actually put in there other than by looking at the URL. So let's go and support that. Well, what we do is we put query in here as one of the outputs. That's going to give us a red line over here because we don't have that yet. So we're going to put query in there. That's going to pass it on to our home. We're going to put query in here as a string. We're going to get query out here like so. And then we'll just put it in for the value down there. And that kind of routes it all the way through. And let's take a look. Hey, there we go. Ivy, sour, nice. And how easy was that? That was crazy easy and fast, so fast. Okay, well, the next thing we want to support is the details page. So click on this and we can't find HTTP localhost Pokemon 1. So the link here is to Pokemon 1. We want to be able to show details on Pokemon 1. So the way that we do that is we make a different Directus call. So let's go take a look at that URL. And again, we're using that DB. Again, we're using that access token. Again, we're using items and the table name Pokemon. But in this case, instead of just doing the slash Pokemon, we're doing slash and then the ID. So we can do, I don't know, whatever, ID 5. And that gives us Carmelian. Awesome. Okay, cool. So now we know how to go and get a specific item. So let's go back over to our code. And what we're going to do is we're going to create a route for this. So the route would be Pokemon, and then within Pokemon id.tsx, and this bracket syntax, if you're familiar with Next.js, absolutely the same thing. So nice little bit of connection there. And yeah, okay, so here we go. So all right, so let's take a look at this kind of piece by piece. So up at the top here, we're going to bring H and fragment in from Preact. So Preact is essentially a clone of React that's more performant. So you don't use React.createElement like you would with normal JSX. In this case, you use H to create an element. And the way that you tell the precompiler that you're actually doing that is you use this special macro comment here and tell it that for the JSX syntax, instead of doing React.createElement, you want to do H. And then fragment is just how you get the same thing as React.fragment. In this case, it's Preact.fragment. TW is the Tailwind preprocessor. So that's why you have that class, and then it's Tailwind, and then you get your Tailwind classes. And that just makes sure that you only bring in from Tailwind the pieces of the CSS that you actually use. There is a bit of a difference here with Preact. You're using class instead of class name. That's just nice. I like that. And then we bring in what we have before, Pokemon, the DB token. And down here, we have our layout. So we've got our name of the Pokemon, the type, and then all the stats. But of course, that's freaking out at the moment because Pokemon is just defined as an empty object. So let's hit details and see what we get. So we'll go back over here to Pokemon. Click on Bulbasaur, and yeah, okay, so we don't get anything that looks good, but we do at least get a page. So we know it's routing well, and we know that the basic mechanics of the setup are right. So what we need to do at this point is go and make that request to go and get the individual item. So in this case, whatever that ID is, we need to pass that along to our request. So let's go do that same kind of SSR thing. Again, we'll bring in the handlers and page prompts from Fresh Server. And then we'll go and define our handler. So in this case, we are getting back the params ID from the context. So that's coming in as context. And then we're just returning that Pokemon data. So now we can go down into our details and say that our props here are the Pokemon. And then we want to get that Pokemon from the data. And let's take a look. Ta-da! Nice. So that's all gotten that lined up and everything. Okay, so it looks good. So the last thing I want to do in this static side of the house before we get into actual client-side interactivity is to add that header at the top, and then we'll deploy it and see how fast it is to deploy. So let's go and start with our header. So I'm going to go and create another component over here. We'll call it header.tsx, and into there I will bring in a header implementation. And all it does is just put a little blue banner at the top and say that we have Pokemon on there. So, okay, let's go over here to our index.tsx and we'll bring that in. Header. And then down here, we'll put it at the top page. Header. And then on our ID detail page, we'll bring in our header. But again, we got to go back of a directory and we'll put it right at the top. Header. Cool. Let's take a look. Nice header, and click on there, and there we go. Cool. Awesome. Okay, so how do I deploy this thing? So I'm going to go over to VS Code. I'm going to stop our site. And what I want to do is I want to check this into GitHub because I'm going to use Deno deploy, and I'm just going to point it at my GitHub repo and then deploy it from there. So the first thing I'm going to do is I'm going to get init. I'm going to initialize this as a repo. I'm going to add all the files. Take a look. Seems sane. Okay. I like it. Let's commit that as the traditional first commit. And then I'm going to go over to my GitHub. And in there, I'm going to create a repository. We'll call it Fresh Pokemon, and then create it. And I'm going to grab that remote add, paste it in here, and I'm going to do GGP, which is my alias to get push. And that will set it up to main. Okay, looks good. And now let's do Deno deploy. Go over to deno.com. We'll sign in. And we'll create a new, this is my currently deployed project, but we're going to create a new project. We're going to select my GitHub repo. And then within there, I'm going to look for fresh. So I'll take fresh Pokemon 1, which is what we just created. I'm going to go and get the main branch out of there. And then we're going to select main.ts as the file. And then the only thing we need to do is need to set up those environment variables. So let's add an environment variable for the DB. And what was that again? So let's take a look. DB is that 4HE, blah, blah, blah. And then another environment variable for my token. And there you go. And before I hit this link button, I swear to you, on Scout's honor, that I am not going to clip this next section for time. This is as fast as this actually goes. You're not going to believe this. Okay, let's hit link and see how fast this goes. This is nuts. Packaging complete, deployed. Deno.dev. I did not cut that for time, y'all. I've been here the whole time. You and I have been together. We just watched it. That's it. That is as fast as it goes. I swear to you. It's nuts. Okay. So if you're impressed by that, I think you're going to really love the island stuff coming up, which we're going to get into. But of course, in the meantime, if you're liking this video, hit that like button. And if you're really liking this video, hit that subscribe button and click on that bell and be notified the next time a new one of these videos comes out. Okay. So with that done, let's go and add some interactivity to this because, you know, we want to be interactive. So first, let's bring back our localhost. All right. So now we're back and running on localhost. So the functionality that we want to add is we want to add this ability to do this list stuff, right? Because this is going to be using local storage and that all has to happen on the client. So you can add to list and then if you click on a button down here, you get that header update and then you can click on that and you can go see the list and, you know, whatever. It's not exactly cuckoo bananas type interactivity, but it does show important client-side interactivity. So the first thing we need to do is create the infrastructure for this list. So we need a state manager of some sort. And what I've decided to use for that is this EVT package. So it's basically the equivalent of like a trimmed down RxJS. So in this case, you like get EVT from the EVT library, and then it creates like an atom or a subscribable thing. In this case, they're creating a string, EVT text. They're attaching to that, and then every time EVT text changes, they get a callback, and then you can just post new values to it the way that you would post to something in RxJS. And so it's just basically a way of doing event transmitters. Now I'm going to use a slightly different version of this called stateful EVT, which is going to hold the current state as well as doing that nice, you know, post attached mechanism. Okay, so first off, let's bring in EVT into our project. And the way that we do that is by going over to our import map. So I'm going to go over here to import map and I'm going to bring in EVT right there, kind of make it all organized. And I'm going to go close a bunch of these files. I'm getting a little long there. And then I'm going to go and in utils, I'm going to create our list.ts. And I'm going to bring in EVT and stateful EVT. That's what I'm going to use to make it stateful. I'm going to bring in is browser from the runtime. That's going to tell us whether we're running on the browser or on the server. And then from preact hooks, I'm going to bring in use state and use effect. Now preact is just like React. It has all the same hooks, but in order to bring them in, you have to bring it in from the preact hooks library. And then I'm going to bring in our Pokemon type. Our EVT list, which is stateful, is going to hold an array of Pokemon. And then if we're in the browser, we're going to use local storage. So we're going to first post to EVT. So we're going to go get the list from local storage or default to an empty array. We're going to parse that because we're going to store it as text. And then once we parse that JSON, we're going to post that to our data, and that's going to set that stateful EVT list. And then we're going to attach a listener to set local storage anytime that it changes. So anytime we post to it, this code is going to automatically update local storage for us. Now, how do we use this? Well, I am going to define a custom. Now, useList is going to act a little bit like useState. It's going to return the current state as the first element of an array, which is going to be the Pokemon list. And then it's going to have an add function that it's going to return as the secondary function on here. And it's just going to add a new Pokemon to the list. There's no way to clear the list. Whatever, you can add that if you want, but nice functionality here. Okay, so to implement on this, we're going to build this add to list button first. So let's go over here to our source and bring in add to list.tsx. And again, we're going to bring in our Pokemon type, Tailwind, and all the rest of it. We're also going to bring in our use list that we just created, and it's going to build us a button. That button is going to have some Tailwind on it to make it kind of pretty. And it's going to be disabled if we're not in the browser, kind of standard. But when we click on it, we're going to do add, and then we're going to give it that Pokemon. Okay, so now we just need to add that to our card. So we'll go back over here to our card and bring in from the same directory, add to list. And we're going to add a little flag here called allow add, which will allow us to say whether we want this feature on the card. And we'll set that to be a Boolean. And then down in here, we're going to add our add to list if we're allowing add. And then let's go back over here to our home page, and we'll say that we do want to allow add on this page. We don't want to allow add on the list page. So that's why we have this little functionality. Okay, so let's take a look. And I'll go to my localhost, and now we have add to list on each one of the cards. But is it working? So let's find out. So let's go back over here to our list. And what should happen is we're getting called here, right? So this is the add method. And so we should be getting called whenever we click that button. So let's say console.log did add Pokemon. Sure, why not? And now we'll go over here to our console, and we'll see. Hit refresh, hit add to list a bunch of times, and no, we're not actually adding it. Why aren't we adding it? Well, we're not adding it because we're not actually sending any JavaScript to the page yet. There's no JavaScript that's going to the page. Therefore, all of the stuff that we just wrote for add to list and all that, it never made it to the page. Why did it not make it to the page? Because it's not an island. Islands are the only way that you can add interactivity to the page. So let's talk about what islands are. Okay, so think about a page like this page. This is the Nike Air Max XP page, right? Big old page. And you got all this real estate up here, and all this sea of page. But there's only a few sections in here that are actually interactive on the client. In particular, this section over here has a lot of interactivity. You can go and click on the different types of shoes. You can click on the different sizes and so on and so forth. But this section here is probably static, right? It may have, maybe a little bit of implementation around it to kind of do, responsive stuff. Maybe it does, maybe it doesn't. But most of the page, a lot of the page is actually static. And so what islands do is islands basically say, hey, you can define the sections of your page that are dynamic, and those are the only sections that are going to get the full React cycle, the full rendering and everything else. That way you avoid that whole reconcile thing. You're not reconciling this whole page, which is massive. I mean, there might be a lot of tags to do these kind of static markup sections, but since they don't actually change on the client, you're just paying a lot to go and kind of re-render those in memory when they're not actually going to change. So what you want to do instead is be selective. You want to say, okay, only this section is going to change and only this section is going to change. And then you can be very precise about where you want to put your money in terms of the client-side JavaScript, and that makes it much faster to actually get that code out to the client, and that makes your time to interactive a lot faster. Okay, so how do we do this? Well, let's go and check how hard it is to do an island. So what we need to do is take that add to list button and simply drag it into islands. There's a counter in there already. We're going to get rid of that. And then over in our Pokemon card, we just need to say that it's now over in Islands, localhost, and now we can see that we're downloading some stuff to the client. So what are we downloading? Well, we're downloading our main, which is coming in at a stunning 752 bytes. And we're bringing in our add to list island, which is coming in at 27.3 kilobytes, which, isn't terrible. And then we're bringing in a 5.5 kilobyte chunk, and my guess is that that's probably pre-act. So let's bring that back and take a look at the console and see, add to list. There we go, cool. So now we actually have client-side functionality, and we've got a lot of Ivy stores in there. Okay, on our window.local storage .set item list to be an empty array. There we go. That's just going to reinitialize that so I don't have a lot. Let's take a look, and we'll add Bulbasaur and Ivysaur. Okay, but we don't know. Did I add that or not? We don't know because we don't have that counter up here in the header. So let's go and implement an island to put the counter into that header. And again, it needs to be an island because this is going to be interactive on the client, right? In this case, we're going to go and update that whenever it changes. So there is some client-side interactivity. So we're going to call this header counter.tsx, bring that in, and we're going to define that header counter. We'll bring in that list from useList, and then we'll just put on the list length. All right, so let's go over here to our header, and we'll bring that in. So bring in header counter from that island, and then we'll put it over at the end of the bar. We'll wrap it in an anchor, so you go to /list. Take a look, and there we go. Oh, we got 18. I guess I didn't clear it out properly. All right, so there you go. We got our 18 Pokemon in there, and if I go to list, that route is undefined since there's no list.tsx over here that would show us our list. So let's go build our list. Let's go over here to routes, do a new file, list.tsx, and bring in a basic implementation just so we can see a header. There we go. Got our header. Nice. Good to go. Okay, so now we want to show a big old list of all the 18 cards that we got going on here and here, right? But because this is all on local storage and that's all on the client, that means that this entire section down here needs to be an island because all that data is on the client. And so all the rendering needs to be done on the client side. Okay, so let's go and do that. So let's go clean up a bunch of this stuff, and then we'll go and make another island. We'll call this one list.tsx. And in there, it's just going to do the same stuff we had before. It's going to bring in that Pokemon card that we had. It's going to bring in that use list. It's going to use that use list to get the current list. And then it's going to just use the same Pokemon card. So that's one of the great things about this framework is Islands is not some completely different mechanism. You can still reuse all the same React, and all the hydration is done using just properties. Like in this case, add to list. The only stuff that's actually coming in to add to list is the Pokemon, and that is all JSON serializable. And what the framework is doing all of that serialization for you to hydrate those islands in the right spots. Okay, so now we've got our list island. Let's go back over to our list page. Okay, so let's bring in our list island from that directory, and then we'll go and use it. List island. Okay, and there you go. We've got our 20 Pokemon. Awesome. Okay, so this is showing you how to do client-side islands. Now, one thing I really want to stress here is how cool it is that basically these little islands down here, which is what those are automatically connecting to this island back up there using that lightweight EVT mechanism, right? So I hit this button that does that EVT post that then, because of that subscribed use effect over in our custom hook, then does that attach and then automatically sets the local state, which is then updating that count. Just really clean, really nice. So that's how you can basically have the different little pieces of interactivity on the page kind of talk together in a very seamless way. Okay, but now, of course, our fresh Pokemon is behind the times. So let's go and take a look at our fresh Pokemon. It doesn't have the add to list, and it doesn't have that thing up in the header, that counter. So let's go and implement it on it then. So we'll stop this, and then we will add our changes. Let's take a look. What changes do we have? We added a few things in here. Okay, there we go. And now we are going to commit, call it client-side islands, and we'll push it. And now hit refresh. And there you go. Nice. Okay, very cool. So let's see, add to list. Very nice. And we'll hit that. There we go. So again, I didn't cut anything, a little bit of burbling there because that was just me, whatever, waiting for the refresh. But that's as fast as it went. I mean, it was like 2 seconds, 3 seconds until it deployed. Very cool. Okay, so the last thing I wanted to show was how to do kind of a traditional API mechanism. And they actually support that. So let's take a look. So again, I'll boot up our app. We'll go over and do our Deno start with our environment variables. And now I'm going to go over and take a look at our API routes. Currently, there is one API route in there. It basically just gives you a joke. Why do Java developers often wear glasses? They can't. Oh, God. Okay. It's got a bunch of bad jokes. And okay, so what we're going to do is we're basically going to wrap up the code that's here, this one, all the way through here as an API request. So on the client side, we're going to be able to run this search API. We'll create a file and we're called search. We'll give it a query, and that will return back the Pokemon that match that. Okay, so let's go and build that. So over in here, I'm going to create a new file. We'll call it search.tsx. And we'll bring in our implementation. That's got our DB and our token that we got before. This is exactly the same code as we had before. We got that request, we got that context. But in this case, it's coming in on the URL search params. We got our Pokemon, and we're going to use that exact same DB and token to go and fetch the data, and we're going to return it as stringified. So let's take a look, and we'll go over here and go back to our localhost, and then do /API/search, query, Ivy, and there you go. Boom. Ta-da! The API. Wow. Awesome. Cool. So if you have something where you want to hide, for example, the DB and the token from the user, you don't want to put those all the way to the client, then this is a really nice way to do that. Okay, but in this case, we also want to do some client-side interactivity. So what we're going to do is build a fully dynamic search page, so that uses our new API. So to do that, we are going to start, because we know this is going to be fully dynamic, by building an island. And we'll call it live search.tsx. I'll paste in my implementation. And so what we've got a live search page, and it's going to have some state. It's going to have the Pokemon. This is very similar to what you might have seen every time in React when it comes to making client-side calls. So we're going to have a state that's going to hold the Pokemon. We're going to have a query. It's going to have that text. And then every time we do an on key up, we're going to set that query with a target value, and then that's going to bind that to that input. And let's just take a look and see how we were going so far. So we have our live search island. We then need to have a route for that. So let's go over here and create a new file called search.tsx, where we then bring in that island. All right, so we're going to bring in live search from that island live search, and then we're going to put the header on there. And it's basically just like our list, but in this case, as opposed to bringing in that island for list, we're bringing in the island for that live search. All right, let's hit save. All right, so now we can go back over here and we can do search, and that brings up our route. Awesome. And we can type in Ivy, but nothing's happening because we're not actually making that request. So let's go and add the use effect to make that request, but we'll do it in live search because it needs to be on the client. So to do that, we'll just use a use effect where we will add a dependency for query. So anytime query changes, which means on every key up, we'll make this fetch. That fetch will go to that API search. We'll encode that query component. We'll get back the JSON, and then we'll set the data in the Pokemon. All right, let's hit save, and we'll do Ivy again, and there you go. Bang, right? Simple. So this shows you a bunch of the different mechanisms that you can use inside of this really nice next generation web server architecture. But of course, let's try it out. Let's get it actually sent up into production. And so you can see for yourself just how easy it is to do this. Again, all we need to do, because the project in GitHub is linked with the Deno deploy, is just deploy it. So we'll just do git add a, git commit, client side searching, and then post it. And let's take a look. One last time, over here to our fresh Pokemon, take a look, and we'll do /search, and there we go. Nice. Very cool. Oh, I didn't actually. Let's go over and do the Lighthouse Score. So let's go over here to view details. Let's just see how fast these pages are. So let's go over to Inspector and then go to our Lighthouse and analyze a page load. And let's see how fast is this page. What's my score? Not bad. Check that out. 100. Bingo. All right. Well, of course, all of this code is available to you on GitHub for free. We will figure out a way to get you the data. So if you want to try this out for yourself, you don't have to go and try and replicate all my data and all my assets. In the meantime, of course, if you like this video and you found it helpful, please comment. It's also always great to hear what you enjoyed about the video, what you didn't like about the video. And then, of course, hit that like button if you really like the video, and subscribe if you feel so inclined. Hit that subscribe button and click on that bell, and you'll be notified the next time a new Blue Collar Coder comes out.